Hello guys, welcome to the final chapter of Unit 4 of the Advanced Java course. So in this chapter I'll just teach you a few more sorting algorithms. So the first sorting algorithm I'm going to teach you is the merge sort. So the merge sorting algorithm uses a divide and conquer approach to sort an array. So it works by splitting an array into two groups with a sort of an equal number of elements in each, and it sorts the groups separately and then merges the two groups together in the end. And merge sort is known to be one of the more efficient sorting algorithms. So let's look at the merge sort program that I've had here. So first I'm going to import scanner because we're going to input data. And then if you want, you can pause the video and sort of look over the code I have here. Right? So first we're just going to create a merge sort method right here, and we're going to have an array and parameters low and high, and the low and high just tell us the lowest index and the highest index. So they tell us where the subarray we want to sort starts and then when it stops. And then we're going to declare a variable n for the length of the array of the inputs, and we can only sort an array if the low index is less than a high index. So otherwise the array would be one number, or it just simply wouldn't exist. So next we're going to calculate the midpoint, which is just the low and the high divided by 2, the average really. And next we'll merge sort the left half and then merge sort the right half. And then after that we'll finally merge both arrays. So we need to return numbers since we just used an integer array. So the next part is the most crucial part of the program. It is where it's the part that merges the arrays together. And we'll create a temporary array to hold those values. So I have a temp array. And the left array starts at the lowest index, and the right array starts one position after the midpoint. And k is just the index of the temp array. So using a while loop, which we have here, we're just going to merge the two arrays together, and that translates to while the left index is less than or equal to the midpoint, and the right index is less than or equal to the highest index. So if the number on the left side is, then we'll increment the left by 1. Otherwise, we will just set k equal to the first element of the right array and then increment the right array by 1 right here. Then we'll increment k by 1 because we need to put another element in the temp array, which I have done here. Next, if the left array is less than or equal to the midpoint right here, we will just sort the left side. And if the left side is completely used, we'll just start sorting the right side. So lastly, we just need to copy the arrays into each other, and so we're just going to combine them and put them back into the original array in the appropriate positions, since the original array does not contain the sorted numbers. The array we are merging is the merge starting at the low position and then again ending at the high position. Alright, so now I'm just going to run the program. Here we go. So I'll just do, how many numbers do I want to sort? I'll just do 8 since it's the even number. So we're just going to enter some random numbers. So I'll start with 1, 25, 87, 43, 12, 37, 90, and 64. And here so here's the numbers I entered, and this is the sorted order. So as you can see, it works just quite nicely. Alright, so the next sorting algorithm I'm going to teach you about is the quicksort. So quicksort basically works by picking a random number and calling it the pivot, and then putting it in its appropriate position. So this repeats every round until the array is completely sorted. So all the numbers before the pivot are less than the pivot, and all the numbers after the pivot are greater than the pivot. So quicksort is pretty efficient, and it's used more commonly in complex algorithms. So quickly just take a look at the quicksort code. Pause if you need to. Okay, so first to make this, we're just going to start with the method quicksort, and it'll have parameters low and high, but it'll also create another method called split, and this method's going to do all the magic. It'll just pick a random number as the pivot and split the array at that point. So first we're going to call the method, and then we'll create the actual method later. Split will just return the position of the pivot element. Now we can assume the element that is selected is in its correct position. That's how the pivot will sort of work. So we want to quicksort the part before the pivot and then quicksort the part after the pivot. So now we will create a recursive call for quicksort. And so we can quicksort the first part and then quicksort the second part. So we'll use position -1 because the pivot is position and its correct position. Then we want to quicksort the second half. And now we need a terminating condition. And if the low is less than the high, then this will recurse. But if the low is greater than the high, then the quicksort will terminate. So it makes sense. So now we're just going to create the split method right here, and we will set this pivot equal to the first number of the subarray, not the first element of the whole array. And we'll keep moving left and right until both arrays cross each other. And while the left is less than the right, we want to continue the left loop and the right loop. And while the left element is less than or equal to the pivot, and the left index is less than the high index, we want to move it to the next position. While the right element is greater than or equal to the pivot, we want to move to the previous position. So just take a look. It's pretty much translated here. And if the left array points to a number greater than the pivot and the right array points to a number less than the pivot, we want to swap them only if left is less than right. So that's put right here. And it's possible that after the while loop, the left loop will have surpassed the right loop. So now we want to write another if condition right here. And if the left is still less than the right, we'll create a variable called temp and hold the left array element. We'll set this equal to the right array element, and then we will set the right array element equal to temp. So now they're swapped, basically. And then we need to put the right array's number in the pivot's position. So now we'll put the pivot in its correct position. Add this, so look at this little bit of code to print the array. And then we're done. So now I'm just going to quickly test this code. So we're going to say we want 6 numbers. So we'll do 1, 43, 87, 62, 1, 4, and 12. And there we go. It works. So the last algorithm you're going to learn about is the heap sort. So as you can probably tell, heap sort uses heaps, right? So in the last chapter you learned about heaps, which is pretty foundational for the heap sort. So the heap sort works by using heaps to store a list of numbers and then retrieve and remove the smallest one. So by that logic you can tell that heap sort is pretty efficient and it's very commonly used. So take a look at this code, and you can pause the video at any time to look and copy it down. So in order to make the heap sort, we're going to create 4 methods: the heap sort, the heapify, the max heap, and the swap. So the heap sort method is like an umbrella over the other ones. So the other methods make this heap sort method work. So the heapify method will make sure the array is a heap and make sure it satisfies the heap property. So if you remember from the last video, a heap property is the property that every node is greater than or equal to each of its children nodes. So if it is not, it will just use the swap method in order to swap the 2 nodes, so it satisfies the heap property. So now that you've gotten an overview of the main parts of the program, let's get coding. So first we're going to declare a integer variable n, and that will represent the length of the array -1. We need that because we will not be heap sorting the root. The root is already sorted, so the length of the subarray will always be 1 less than the length of the original array. So in the heap sort method, we'll be calling other methods that we'll be creating later. We'll just first need to heapify the array to make sure it satisfies the heap property. So using a for loop, we're just going to swap the numbers, right? And if they don't satisfy the heap property, we will set n to n equals n-1 right here, because after swapping there'll be one more sorted element. So after doing that, we will use max heap method to make sure the code satisfies the heap property. Next we will just create a heapify method right here. As I mentioned earlier, we will set this equal to the number length -1. So using a for loop, we will call the max heap method to make sure that the heapify works. Now we will need to actually create a max heap method. So to do this, we will first declare two variables, left and right. We will set left to 2 times mid, which is the midpoint, and we will set the right to 2 times mid plus 1. So we will set the max equal to mid, and using if statements, we will decide whether it is equal to n, or the left side it's less than or equal to n, or the right side is greater than the max. So we will set the max equal to the right. And if the max is not equal to the mid, we will use the swap method to swap the two nodes. And max heap makes sure this satisfies the heap property. So now we're going to create a swap method under here. We'll first create a variable called temp, and we will set this equal to the number in the first index. And then we will set the number in the first index equal to the number in the next index. And then we'll set the number in the second index equal to temp. Right? So we do this so we make sure we don't lose any numbers from our original array. This is non-destructive code editing. So let's just run the program quickly to see if it all works and comes together. So we're going to sort 4 numbers. I will do 1, 90, 32, and 7. And what do you know? It works. So guys, congratulations for making it through the Advanced Java course. Thank you for taking your time to go through this course. YCPC hopes sincerely that you will apply these skills in the coming future. So go out there, use your skills, and have fun coding.